We're going to use limits to evaluate things that we've already done before without limits. So things like horizontal asymptotes, holes, vertical asymptotes. So we're just going to formalize this using limits. So when we look at horizontal asymptotes, we're looking at endpoint behavior. So we're looking at what's happening at plus minus infinity. When we do that, we really can ignore the parts that cancel out. And we can then compare the ratio of the highest power terms, and we can see that we're going to have a horizontal asymptote at 3. So what does this look like? We're just going to formalize this and write it this way. So the limit as x approaches infinity of our f of x function, we're going to say that because we just compare those powers, we're going to say that the limit is equal to 3. And then we're going to do it same for negative infinity, because as we approach negative infinity, the same thing is going to happen. We're going to end up with a horizontal asymptote at 3. So then based on that, we can just draw in a horizontal asymptote at y equals 3. Again, this is nothing new, other than now we've put it into this limit notation to show what we've done. When we talk about a hole, before what we did was we canceled out. Okay, we know it's a hole because it cancels. And then we plug in x equals 1 into here and here, and we get 3 plus 1 over 1 plus 2, and that determines the y coordinate of the hole. So we've done this before, but now we're just going to write it more formally. So the limit as x approaches 1, we're going to end up with 3 times 1 plus 1 in the numerator. We're going to end up with 1 plus 2 in the denominators. This part canceled out, so we can evaluate this limit, and we end up with 4 over 3. And so what then we can conclude from this is the hole is going to be at x equals 1. When we plug y in, we get 4 over 3 as the limit. And so if I have my coordinate here, this is going to be at 1, and maybe 4 over 3 is going to be that point there, and it represents the hole in the graph. So we've done this before. Again, now all we've done is we formalize this with a limit. So we have vertical asymptotes. The vertical asymptote in this case happens at x equals negative 2. That's when we're going to divide by x plus 2, so we have a vertical asymptote at negative 2. Now, as I approach negative 2 from this side, we want to know what's happening. Okay, so as I approach it from that side, what we can do is we can plug in negative 2 into this expression. So in the numerator, I get 3 times negative 2 plus 1. That's going to give me negative 5 in the numerator. And this is where this is kind of new thinking, but we now have to consider which side of 0 am I dividing from. So as I approach 2 from the negative 2 from the negative side, I have like negative 2.1 on this side. So when I put negative 2.1 into there, into this x, I'm going to end up with negative 2.1 plus 2. That's going to give me a negative number close to 0. And so what ends up happening is I'm approaching 0 from the negative side. So I say I'm dividing by negative 0. The fact I'm dividing by 0 is going to give me infinity, and the direction is based on the numerator sign of negative and denominator sign dividing by negative. Well, negative divided by negative is positive. So we can see that from the left-hand side, I'm approaching positive infinity. And then from the left-hand side, I'm probably going to be going this way. But let's analyze this. As x approaches negative 2, I plug in negative 2 into the numerator. I get 3 times negative 2 plus 1 is negative 5. And now as I use numbers on this side, for example, negative 1.99, if I plug it into here, 1.99 negative plus 2 is going to give me a positive 0.01. It's going to give me numbers close to 0 that are positive. So I'm approaching 0 from the positive side. So if I'm dividing by 0, I get infinity. And if I look at the signs, negative divided by positive is going to give me the negative infinity. And so that's why, that's how I can justify that the limit is going down to negative infinity. So it's going down on this side, up on the other side. And once I have that, I can just kind of sketch in my graph. And I've used my limits to establish my vertical asymptotes, my horizontal asymptote, and my hole. Okay, so this is using the limit notation then, formally, to do things we've done before.